So let's get started here, folks. Welcome to this morning's Lockstep Technology Group Tech Talk, the second one of the year. I am Pat Cavell. For those who never met me, I'm a pre-sales technical architect with Lockstep here in Baton Rouge. And today, I thought I would venture into sort of an area that's a bit tangential to networking, and that's networking security, and more specifically, sort of the fundamentals of it. The origin story behind this tech talk is the fact that I've been working in technology for many years. One of my biggest focus areas is in networking, providing guidance to customers on how to architect networks, solutions, that sort of thing. And a lot of my customer base are smaller organizations or organizations that have lean IT, particularly in the public sector space. I work with a lot of K-12, some higher eds, and local governments. And I find that in many cases, they struggle sometimes with their network and making sure they cross the T's and dot the I's, and particularly in the security arena, making sure they're securing in that environment. So I thought I would put together a tech talk that offers what I would consider some personal guidance from my background as to things that perhaps you should be looking at doing at a minimum, and maybe some other things that if you have the wherewithal to do them, to make your network security posture a bit better. Now, this will not be the be-all and end-all of guidance on this because I don't hold that patent. So if you have some ideas that you think might be useful, feel free to shout them out in this tech talk. We are recording this, and so after the call, I will be sending the recording link out to everybody on my customer email list. If you're not on my customer email list, let me know, and I'll be glad to add you to that. So you'll be copied on events like this, tech talks and networking classes, things like that. I do ask that if you don't mind, mute yourself. I think I'm hearing some feedback from someone, maybe if you can mute yourself. But if you have a question, feel free to unmute yourself and shout out your question. If you would like the slide deck after this is over, I'd be glad to provide that to you. So without further ado, we're going to move forward here. Let's see. A couple of pieces of administrivia. For those who are not aware of it, we have our annual Lockstep Customer Crawfish Boil coming up in Baton Rouge, Thursday, May 15th. I think it's like 5 to 8 p.m. You are invited, but if you do want to show up, please ask for an invite and click on the register button on that invite. There's no charge for the crawfish boil, and it is usually pretty darn good crawfish. So again, May 15th in Baton Rouge. For those of you who are out of town, feel free to drive in and spend the night in Baton Rouge and have a good time. Many of you know that I teach some networking basics classes. I have 2 levels of that class. One is a 1-day networking basics for help desk personnel. And then I have a 2-day networking basics class that is a bit more in depth. That 2-day class I will be teaching on May 21st and 22nd here in Baton Rouge at the Lockstep office here. I have 1 seat remaining. If you or someone in your organization would be interested in attending that, let me know. It's on first come, first served basis. And lastly, our next tech talk is going to be Thursday, June 12th at 9 a.m. And our speaker will be Laddie Kelly of Meraki. I think many of you know Laddie. Laddie's been with Cisco for many years. He was a colleague of mine, and he has been a Meraki practitioner for many years. Matter of fact, about a year ago, he moved into the Meraki organization, and that is all he does. He came on last year, I believe in December, and did a tech talk, sort of a tips and best practices, part 1, and now he's coming back for a part 2. Because there were things that he said he'd like to cover that we just ran out of time on. So be looking for an invite for that tech talk. I'm going to give a disclaimer here. This session is focused on what I think you should do and not so much on how you should do it. Simply because we don't have the time to go through that. And the guidance I'm giving you in many cases is vendor agnostic. So how you do it will depend on which vendors you're using. So I try to stay away from that as much as possible. Here's our agenda. We're going to go through all of these, and I'm going to try to offer some guidance in every one of these areas. Again, if you like my guidance, great. If you don't like it, that's okay too. And if you have something you'd like to add, please chime in. So the big picture, what's this all about? This is all about, or this whole idea of network security or security in general is all about servicing what I call, or what is known as, the CIA Triad. And that's confidentiality, integrity, and availability. The confidentiality is basically keeping your information private. We don't want unauthorized prying eyes viewing or having access to our corporate information. We need to pay attention to maintaining that. Integrity. We want to make sure that our information is accurate and no one changes it. There's no man in the middle that gets in there and messes with our data. And lastly, availability. You can have all the confidentiality and integrity in the world, but if you can't access your system because, for example, you've received a denial of service attack, then that's not good. So availability is making sure your systems and data can be accessed when needed by authorized users. Now, one thing I would suggest you do, and I know many of you have heard this term many, many times over the last several years, but I think it's a mindset we should all be adopting, and that is the zero trust mindset. And that is the idea that for you to, whatever job you have, whether you're in IT or whether you're a user in your organization, and you need to access the information of this organization, we will give you access only to what you need and only in the fashion you need it, whether it's read or write or whatever. And we should periodically re-verify, are you who you say you are? You've been online for 8 hours? Well, let's just make sure that's still you. So zero trust is all about, as Reagan would say back in the day, I'm dating myself, trust but verify. So a robust security posture really requires a lot of motions. And that's referred to in many cases as defense in depth. So that's all about securing your endpoints and your devices, securing your identities, securing your applications and data, and now securing the cloud. And lastly, securing your network or your network infrastructure. And that is our focus today, securing your network infrastructure. For those of you who have attended my networking basics class, this is a mantra I repeat a lot in that class, that in today's world, you cannot be a network engineer without some cybersecurity skills. And I would turn that on its head and say, you really can't be a true cybersecurity practitioner without a certain amount of networking skill. So I would encourage anyone who's a network engineer, make sure whenever you can ramp up those cybersecurity skills. Mine are better than they used to be, but I still aspire to be much more knowledgeable about it. And I actually work on this just about daily, trying to improve my cybersecurity skills. And I encourage you to do the same. So our scope today, we're not going to boil the ocean. We're just going to focus on what I would call basic blocking and tackling and what I think are some best practices. So take it from the perspective of, at a minimum, perhaps implement these controls that we're going to walk through. Because I know, we all know it's a battle. You've only got so much time, so much money, and so much expertise. There's only so much you can get done, and you do the best you can with what you got. Now, for those organizations that are really resource constrained and struggle at doing any of these capabilities, this might be the time to look at perhaps a managed security service. And as it happens, LTG can help in that area. We have a very large security practice, and we'll be glad to chat with you about what we can do. We can do assessments, and we can do a variety of bespoke or standard security managed services. So just let us know if you're having trouble in that area. So action zero, what you should do first? Well, I think you should document your network, okay? Because you can't protect what you don't know. Keep the documentation updated. I see this time and again. Well, either I see customers where there is no documentation about the network, and so you really kind of have to struggle. Okay, well, what's this look like? We go to the whiteboard. But also, in many cases, they have the documentation, but it's 5, 6, 10 years old. Make sure you document all your networking devices, your wired, wireless security, all of them. Have a good topology diagram. Your addressing scheme, make sure you've documented that in your various DHCP scopes. Document your VLAN architecture. Document your wireless SSID architecture. Here's the guest SSID. Here's a contractor one. Here's an internal one, et cetera, et cetera. Very importantly, document your external connections. Typically, you're going to connect to at least the internet, so make sure you have a full understanding of that connection. But you may also have cloud connections, say to an Azure or an AWS, and you may have some supply chain partners that you're connecting to. Make sure you really document those. Now, this whole documentation process, if you can automate it, that's great. And there are many tools that can assist in that. As a matter of fact, there are lots of network management and monitoring tools that can assist. An example might be in the Cisco world. It might be the Cisco Catalyst Center. It might be SolarWinds or PRTG or Manage Engine, and on and on and on. All the vendors tend to have solutions. Now, one of the things I like are the cloud managed network infrastructure solution. Examples might be Aruba with Aruba Central or Meraki with Meraki Dashboard. The nice thing about those, to a great extent, they're self-documenting, and that makes that the documentation is built and the documentation stays fresh. I really like that feature, particularly if you're a lean IT organization. Now, for smaller networks, you can always use things like Visio and Excel, or any kind of tool that works for you, but document it. That's the important thing. And again, folks, if you have any questions, feel free to shout them out. Let's see. Action number one. This may be a duh moment, but I'm going to state it anyway. We'll talk a little bit more detail about it. Deploy an enterprise perimeter network firewall. And before we go further, I can't stress enough that if you're managing a firewall, you really need to understand the concept of the 5-tuple. For any kind of basic firewall access control policy and for managing traditional zone-based or stateful firewalls, you live and die with the 5-tuple. And the 5-tuple is this. It can be found in the IP header of a packet and is essentially these 5 things. The source IP address, the destination IP address, the source layer 4 port, the destination layer 4 port. Example is port 80 or 443 or something like that. And then what protocol are we were talking about, TCP or UDP? You tend to build your traditional access control policies, your ACLs, based on that 5-tuple. Now, always directionality is key in this because it's easy to get confused with creating an ACL that works in one direction, but it doesn't work in the other because maybe you've reversed the ports and destination addresses incorrectly. So understand the directionality of the traffic and how to appropriately understand and build the ACLs. And then lastly, for those of you who attend my networking basics class, understand the OSI model. It is your friend. I know it can make you fall asleep if you're reading about it at night, but it's extremely useful to understand the OSI model. So deploy a firewall, but not just any firewall. Do not deploy a traditional layer 3 or layer 4 stateful or zone-based firewall. And I'm particularly talking about at your enterprise perimeter. I would strongly suggest deploying a next generation firewall. Examples, Palo Alto, Cisco FTD, Fortinet, any of those, and there are many others. So what's the difference between a next generation firewall and a traditional layer 3, layer 4 firewall? Well, there's a lot. The NGFW encompasses all that stateful layer 3, layer 4 capabilities like those ACLs, but it can do things like layer 3 through layer 7 inspection, IPS capabilities, deep packet inspection, application visibility and inspection, malware protection, URL filtering, SSL decryption, a whole lot of other things, and much more. You're going to want to make sure of and tie into some intelligence feeds. For example, Cisco Talos or Palo Alto Cortex, Mandiant or VirusTotal, and again, there are many others, but make sure you have those current feeds tied into your firewall to keep that information fresh. One of the things about next generation firewalls, they tend to be able to do what I call context sharing with other tools. For example, if you've got some sort of XDR tool that your firewall, your next generation firewall, can feed information into that XDR tool, which maybe your email security device may be doing. Maybe your EDR endpoint tools may be doing them. You're feeding all this information, and maybe there's some context built. Oh, we're seeing this here and here and here. And maybe there can be an action taken. Perhaps, for example, the XDR tool may tell the firewall, hey, block this user or device. For public-facing servers, put them in a DMZ, isolated. These are the folks that are devices that are being exposed to the internet. And what we do not want to happen is if some bad actors come in and they somehow get some access, unauthorized access into those DMZ or public-facing servers, we don't want them to do bad things by spreading their malware east and west. Keep them in a secure DMZ. Make sure you understand the licensing that comes with your firewall. That's one thing you didn't have to worry so much about with traditional firewalls. You just got the firewall and all the features were there. Nowadays, there's so many features that you can enable or not enable that you want to make sure that you've purchased and have turned on the appropriate licensing so that you can get all that richness. Okay. Now, one thing about a next-gen firewall, and as you can probably see from what I've already talked about, it takes more care and feeding and probably more skills than a traditional firewall. So just be aware of that. It's a bit heavier lift, but it's a huge payoff. So firewalls by default block all incoming traffic. And what I mean by that is traffic initiated from a less trusted network to a more trusted network. And this is a very good thing. Now, firewalls by default tend to allow all outgoing traffic. Now, what I mean by that is traffic that's initiated from a more trusted network to a less trusted network. That's not so good. Some of that outgoing traffic really should be blocked. But how do you choose what traffic should be blocked? Here's a way you might want to go about it. Let's say for 30 days or so, you run reports on some of that traffic. Maybe you're looking at firewall logs, maybe you're looking at Wireshark, or maybe some other tools that you have. Review those logs after about 30 days or so, and then ask and answer this question. Which of that traffic must we allow for legitimate business purposes? If there's traffic that doesn't pass muster on that question, then maybe we should be blocking it. Okay? So you're always going to run into a situation where you're going to block stuff and you're going to find out, oh, yes, that was an application we really need for our organization. You have to open up. But hey, that happens. Now, be cautious blocking outgoing traffic to TCP ports 80 and 443 because so much of that traffic is on those ports, particularly 443. And nowadays, you really need to be careful about blocking outgoing UDP port 443 traffic. Notice that's UDP 443, and that is QUIC. You're probably seeing a lot of QUIC on your networks now. That the use of QUIC is really growing. You may ask, what is QUIC? QUIC has been a protocol that's been around for well over a decade. It was defined by Google. One can think of it this way. We like using things like SSL and TLS because it gives us good, secure communications, at layer 4 and above. But it's TCP based. QUIC is UDP based, and one of the benefits of that is that not only do you get the security, but you also get a fast setup. You get low latency. You don't get things like when a TCP session runs into roadblocks, it really slows down significantly and has to ramp up. QUIC doesn't suffer from that. So we're starting to see a lot of what used to be, say, TCP 443 now become QUIC traffic. Okay? Use a good DNS security solution. One example might be Umbrella, and block all outgoing DNS requests to other DNS servers. Now, you may not be able to do that, but to the extent you can. So whenever a DNS request goes out, if it's not going out to, say, your chosen DNS security solution addresses, then don't let it go out. Okay? And I'll say more about that DNS security later, but put a little asterisk there because I do think that is an absolute must is DNS security. When you're trying to document, what you need to block and what you don't need to block, I put together a little spreadsheet, for example, like what I've got down there, where I've listed in this example the source or the phone subnets, the destination of the voice servers. If it's TCP traffic coming from any port destined to 5060, well, that's my SIP voice signaling. Well, I need to probably allow that. Okay? Make sure you limit lateral movement with your firewalls. Do not allow internal users and devices wide open access to the crown jewels in the data center. That's your servers, your applications, and their data. Unfortunately, I see this being allowed in many, many of my customers. It's as if once you're inside the network and you're an internal employee, you can get to anything. We should not be doing that. Consider deploying an east-west firewall. If need be, this could be a simpler thing like just a layer 3, layer 4 stateful or zone-based firewall. But you need to segment off your crown jewels, as I call them, from all folks, whether they're internal or guest or whatever. Now, that east-west firewall and your enterprise firewall could be the same. They could be the same one if it has the bandwidth and the processing capability, and they happen to be co-located. So they don't necessarily have to be different devices. Okay. And at a minimum, here's one way you can do it is deploy, make sure that at a minimum that your data center subnets or layer 3 disconnected, or they're on another layer 3 set of networks from all your other users, including your internal users. At a minimum, that gives you the ability on a layer 3 switch or router connecting all of this to put in ACLs to protect your data center VLANs. That's another way to do it, sort of a poor man's firewall, if you will. Action number 2, segment your networks. Everybody should not be on the same VLAN. Okay? And limit access to only those segments required to perform your legitimate mission. Okay. VLANing offers a lot of benefits. You're going to get better network performance, scalability, improved security because you can put ACLs blocking traffic between them. And one of the things I like about it reduces the blast surface for network issues. So when a problem occurs, your ability to determine where did it occur and how can we limit it is significantly enhanced because it's happening over in that VLAN over in that building because we've done segmenting. IoT devices. These are very pernicious little devices. We need them to conduct our business, but quite often we have no control of these. Quite often I find that my customers are told by some other non-IT department, hey, I need to deploy these IoT devices, whether they're sensors or whatever in the network. And you just have to make sure that the network can support them. You want to make sure you put them in their own VLANs and limit their access because you have no idea of the posture or the health of these devices. Make sure you understand your environment, your devices, your users, so that you can understand the best way to VLAN things out. And limit your broadcast domain size. Don't make VLANs with tens of thousands of devices in it. That's a recipe for disaster. Make them. There's no set size for a size of a VLAN, but it just depends. But don't make them too big. Now, you could also block intra VLAN traffic. One of the ways you could do that is what's called a VLAN ACL that various vendors offer on their switches. Or if you've got the resources and the skills, you could look at doing some sort of micro segmentation, what I would call a sort of a NAC or network access control solution. You're starting to see this more and more and more, and this really helps drive the zero trust implementation, doing micro segmentation. Secure your wireless network. This is one of those areas I tend to find that my customers tend to do a slightly better job here because it's a little easier because you can quite often just go to, say, a centralized controller and make it all happen and put the security in, and it's good across the entire enterprise. But anyway, here's some good thoughts here. Use strong authentication methods for your wireless devices that need access to corporate resources. Don't use any pre-shared key method. Things like WPA2 personal. Don't use that for internal users, please. Use what are called enterprise methods that make use of 802.1x and radius. Say, tie your client authentication to a central IDP, like an Active Directory, where they have to provide at a minimum their Active Directory credentials or maybe a certificate. Which ones to use? Well, if you can use WPA3 Enterprise, that's the best. That's what I would recommend. And by the way, if you're looking to use the new 6 gigahertz bandwidth in wireless environments, that requires WPA3. So you need to be thinking about that. If you can do only WPA2 Enterprise, that's okay. But it's not the best. If you have devices that you don't control the supplicants, they don't have supplicants for 802.1x, then perhaps use MAB. And if possible, couple them with a NAC solution so you can do a little bit more profiling and limit access. So you can not only determine what their MAC address is, but what is this? Oh, this looks like it's an infusion pump for a hospital. Maybe that should be placed on this VLAN because of its mission. And for guest users, limit their access to internet access only. Any questions at this point? And I can't see the chat window, so might need you to shout it out if I don't think anybody's put anything in chat window. So we'll keep going here. Action 4.
No, there's nothing in chat yet, Pat. I'm keeping an eye for you.
All right. Thanks, Ron. Number 4, secure your wired network. Now, here's one thing I find. Historically, many customers have protected access to their wireless networks better than their wired networks. My urgent guide to you is lock down your wired networks. Just because your switches and your routers are physically inside your corporate premises doesn't mean they are naturally protected. No, we need to protect them too. We need to protect that network. So some things we can do at a minimum. Disable unused switch ports. It's not fancy, but it works. So try that. Try things like port security. That's a Cisco feature, but there are other vendors that have similar tools. If you can implement what are generally referred to as implement first hop security tools, things like dynamic ARP inspection, DHCP snooping, IP source guard. These are the kinds of things that keep that access layer healthy, so that if an IP address, so that an attacker over on this port is not able to send out traffic spoofing your IP address when you're on another port, things like that. Making sure that the DHCP queries come from a port that really is authorized to allow DHCP servers to talk on. And if you have the resources for internal managed endpoints and users, use 802.1x and radius for authentication. That's a good thing to do. Or you can use certificates too. Nowadays, just about all endpoints have what's called the 802.1x supplicant, so that should not be a problem. Okay? Use a NAC solution, things like ClearPass or Cisco ICE, and there are many others for your AAA. Assign your ACLs and VLANs to ports dynamically based on AAA results. So, for example, a NAC solution may be profiling a device that connects and says, oh, based on what I've learned about this device and the credentials they provided, we're going to tell that port to put them in this VLAN, and maybe we're going to drop this ACL on that port to limit where they can go. Now, this can be a heavy lift for a resource-constrained organization. We understand that. But to the extent that you can do that, it's just really good to do.
Hey, Pat, you do have a comment in the chat.
Okay, let's see. Let's see. Let me take a look at that. You told that port 443 should be allowed for outgoing traffic. Well, what if some threat actors has a reverse shell connection or beaconing going on that port? Well, things like that could happen. But what we do know, so that's where allowing 443 as a general guidance is because so much of our traffic is 443. You block 443 just across the board, and you're out of business. You have to allow that. That's where you need other tools that can look deeper. That's where something like a next generation firewall comes in. And as Michael just chimed in, that's where things like threat intelligence come in. You're looking beyond the 5-tuple and saying, okay, let's look a little deeper. And yes, we may generally allow 443 out, but as we look deeper into this packet, and some of our threat intelligence or IPS or DPAC inspection tells us, no, we're going to selectively block this. So, but good question there. Action number 5, protect your network infrastructure devices. These are your switches, your routers, firewalls, controllers, things like that. First off, control physical access. In the MDFs, IDFs, your switches, routers, lock doors, have cages, perhaps deploy cameras, perhaps biometrics, although that's something you tend to do in a data center, and that can get pretty hefty. Physically lock down APs and switches that you don't put in comm racks. Use things like Kensington lock. Password protect local access. Someone plugging into the console port. We don't want someone to just walk into a wiring closet, or maybe they, at a school, and they open the door and there's some switches there. Let me plug in, see what mischief I can do. You want to lock down those and make sure they're password protected, disable default credentials, things like that. For remote admin access over the network, that is, disable telnet, allow only SSH and or HTTPS. Use a centralized AAA servers running using perhaps TACAX or Radius, and identity providers like AD. So you log in. We're going to, the switch, for example, is going to go off to the AAA server, which on the back end may go off to AD and says, okay, this is Pat Cavell trying to log in with these creds. Should we let him in or not? The beauty of that is if Pat Cavell leaves the organization, and maybe he leaves the organization because he got fired, we don't want him coming back and doing mischief. So as soon as he leaves, we delete his account in Active Directory. Now, as a backup, if for some reason your TACAX or Radius down, you could say, hey, we could allow access to these devices, these switches, routers through locally stored creds, but only if centralized AAA is unavailable. That can be made to happen. Require MFA. Let me say it again. Require MFA. You log in, you provide your credentials, you pass muster, and then you're getting hit with the MFA challenge. So make sure you use MFA. I don't care which one it is, even if it's just sending a security code in a text message, but do that. Use role-based access. If you're giving a help desk technician access to network infrastructure, do they really need write access? Maybe they just need read access, for example. If you have an out-of-band network management network, that's great. So you can always get to the device, even let's say in the instance of a denial of service attack. you could still get to that device, see what's going on, perhaps stop the attack if you've got an out-of-band network. Perhaps limit access to certain source addresses. Only, say, the network infrastructure team can get in. And you can do things like enable idle timeouts, limit password entry retries. So after 3 or 4 tries, then we lock you out for 30 minutes or whatever, something along those lines. Regularly patch your network infrastructure devices. Always keep your software and firmware up to date. That's kind of a given there. Secure communications between your network infrastructure devices and also between your network infrastructure devices and management servers. For example, we want to stop rogue devices. If you don't do, for example, if you don't secure your routing protocol exchanges, for example, OSPF between 2 devices, a rogue router can make a OSPF adjacency to your router and give you some bad routes and poison your routing table. So secure those with authentication of some sort. Secure your communications with things like SNMP servers or syslog servers. I would also suggest enabling 802.1x authentication for the wireless access points. Now, here I'm talking about authenticating the access points. So when the access points themselves join the network, make sure that they're not rogues. This is not talking about authenticating the clients. I would use NTP, Network Time Protocol. Sync to a good NTP server and make sure you have more than one that you're pointing to. If you can use things like the NIST servers or ntp.org servers, great. This really comes in handy when there's an event and your switches and routers are all have event logs, and you're trying to diagnose the problem, and you're seeing that there is an incident going on, but because the logs are not synced, because you're not using NTP, they all have different timestamps. So you can't make sense of it, or they look like disparate events that have no relationship when in fact they are. So make sure all of your devices are using NTP. And also, if you don't have good timing, you can break some stuff, like certificates expiring prematurely. Active Directory, particularly Kerberos, has big issues when timing is not quite is a little off. Harden your network infrastructure devices. Now, this we could have 3 hours just on this. You could do things like disable unused services. But I'm going to say that at a high level, harden those devices. What you will find is that most vendors have device hardening guides. Aruba, Juniper, Cisco, and I'm sure all the other ones have similar types of device hardening guides, and they're very thorough. Back up your configs and make sure they're protected, those backups. When you make changes, perform change tracking. Who did what and when? Enable logging on your network infrastructure devices, but don't just enable logging, send those logs to a centralized and protected logging server, maybe a SolarWinds or an Agios. But even better, send those logs, if you have the wherewithal, to something like a SIEM, like a security information and event management tool, such as a Rapid7 inside IDR or a Splunk or an IBM QRadar. That's a bit of a heavy lift from a resource and money perspective, but at least send things to a centralized logging server. Configure what's called unicast reverse path forwarding, or URPF. The idea here is to prevent packet spoofing attacks. Now, this happens if you're familiar with multicast. You kind of do this in multicast where you want to send a packet out, and you have to know, I received this packet from this source, and I should have received it over interface 1. So when I want to send a packet back to it, my routing table should say send it back to interface 1. A packet spoofing attack that URPF could stop is one like this. We see a packet come into a router on interface 2. But when you look in the routing table says if packets coming from that network, they should be coming over interface 1. They shouldn't be coming over interface 2. So URPF would stop that type of shenanigans. Disallow directed IP broadcasts. That is the idea that I am perhaps off network or on a different network, layer 3 network, and I'm going to send a broadcast, not to everybody on my local LAN, but I'm going to send it to that particular subnet way over there in that building or over at that company or whatever. But it's a broadcast for that subnet or network. Typically, these should be stopped by layer 3 routers by default. But if yours is not doing that, you want to do that. This is not a good thing to allow. There's very small use cases where you might want to allow directed IP broadcasts. Any questions at this point? Okay. Well, I will continue.
You got one more comment in the chat. It's just a little informative about some of the Palo features.
You want to read it out real quick, Ron?
Says QRadar SaaS is now under Palo's portfolio.
Gotcha. Okay. Well, thanks, Chad. Appreciate that, man. Good stuff. Action 6. And this is one that if you have the wherewithal to do this, implement a network access control solution. Okay. What are some network access control solutions? There are lots of them. Some of the leaders are Aruba ClearPass, Cisco ICE, Portnox. I think Extreme has one, and there are many others. What are the benefits of a network access solution? It automates the process of placing users and devices in VLANs, or can do that. Okay? It can also automate the process of dropping access controls on users. You can do profiling and posture assessment. Now, this gives you better visibility regarding what or who is on your network. And it gives you better criteria for identifying and authenticating and also authorizing users and devices. One of the things people do with NAC devices very early on when they deploy them is they don't turn them on and configure them to do enforcement. They just deploy them to see what the heck is on my network. They might do that for a while, and then once they have a good feel for what's on their network, then they start building their policies, and then they start doing enforcement. So it's a great visibility tool in addition to being a great security tool. It offers the possibility of doing some very granular micro-segmentation, which is a very good thing. And they can typically do some context sharing with other tools. For example, quarantine a device per a request from an XDR2. You know, for example, an XDR2 may say, this is a bad actor. NAC tool or ClearPass, we want you to do this, quarantine this guy. Make him go off to a secluded VLAN where he has to remediate or something like that. For wired networks, this can be a heavy lift for resource-constrained organizations. I fully understand that, but the extent that you can pull this off or outsource it, it's a good thing to do. Now, keep in mind, when I'm talking about implementing NAC, I'm not talking about it just for wired networks. I'm talking about doing it for wired and wireless networks. Okay. What might a NAC deployment look like? And the intent of this is to kind of give you a feel what it looked like, but hopefully give you a feel for what it might be doing. So here we have our enterprise network. There's Bob over on the left on his laptop or desktop, which he's running an 802.1x supplicant. Okay. That's the software he's running. He's connecting to a switch, and this switch is talking to our NAC system. And that switch is configured as what's called an 802.1x authenticator. Okay. And back in the upper left-hand side are all our NAC servers, whether it's ClearPass or ICE or whatever. So those are our NAC servers. They're running 802.1x, and they are referred to as 802.1x authentication. I misspelled that. They're authentication servers, not authentication servers. And then they may, on the back end, be connecting to an identity provider like an Active Directory. So, for example, Bob connects to the network. His switch is configured to profile and possibly do some posture assessment on Bob's PC. The switch is configured as an 802.1x authenticator, and he challenges Bob for credentials, like his AD credentials. And then he does the profiling and posturing. In the middle center upper area, you'll see the results of that profiling and posturing. The NAC system is learning his credentials. His user is Bob. His password is acme123. He's running Windows 10. He's at this patch level. His user agent is a Mozilla 5.0, and he's running a version of Malwarebytes. So we're getting a good feel for who this is and his posture. At that point, this information is sent from the authenticator over to the NAC server. NAC server is going to go to AD and say, "Hey, are those the right credentials for Bob? Can we let him on the network?" AD said, "That thumbs up." So the NAC server goes back to the switch and says, "Let Bob on. And by the way, we might drop him in this VLAN. We might apply this ACL to that port. Maybe we might put a certain security group tag on all of his traffic." And that's an example of how a NAC deployment might work. Any questions about that? I'm being generic when I talk about the NAC servers. Now, notice what I'm showing here is a NAC solution that is based on premise NAC servers. There are NAC solutions that are cloud-based NAC solutions. You don't always have to have your NAC servers on-prem. Now, your authentication, your enforcement points, they're going to probably need to be on-premise for sure. And you're going to have to, in your identity provider, it may be on-prem like Active Directory, but it could be something else in the cloud. Maybe it's Entra ID. Okay, so a lot of variations on that thing. That's Action 7, protect your remote sites and users. The day of all assets residing in your hardened shell of a corporate network is gone. Parts of your network are beyond the castle, and I would say a whole bunch of your network is beyond the castle. Require MFA for remote access VPN use. I would like to think that probably 95% of all of you are doing that. Matter of fact, I'll bet most of you have run into this issue. You go to re-up on your cyber insurance, and the very first thing on the insurer's list, are you doing MFA for remote access VPN? So enable that. Make sure that happens. For site-to-site VPNs, place your VPN head-in a DMZ or external to your perimeter firewall so that you can inspect the incoming traffic. You're coming through the VPN, you're popping out of the VPN into the corporate network. Let's make sure we can inspect this traffic so nothing bad gets through. When you're creating your site-to-site VPNs, limit what I call the interesting traffic to the required subnets only. And I think most of you probably know what I mean by interesting traffic. That basically means on each end of the VPN, which networks on each end can talk to each other, okay? The remote subnets, the local subnets, and vice versa. If you're using split tunneling, be careful. Make sure there is a security perimeter for all that traffic that goes straight out to the internet. You're seeing more and more folks use that. However, you're seeing there are a lot of good tools to make that happen. As a matter of fact, there's a concept about how to do things like split tunneling and giving remote access to remote users, direct internet access to remote users or remote branches. And that solution set is called, or a framework is called SASE, Secure Access Services Edge. And we'll talk about that a little bit. I think someone might have had a comment. Let me check what that comment is. Bear with me. Let's see. Yeah. In a NAC deployment, if a threat actor gains full knowledge of a legitimate user's posture information, including credentials, OS details, MAC address, antivirus configuration, what mechanism can be implemented to prevent the attacker from successfully spoofing the endpoint and bypassing NAC controls? That's a good question. The the thing I see here is that attacker, he's basically spoofing all of that, the OS, the Mac, the configuration. I will say that there is no 100% foolproof protection for networks. That's why you always want to have incident recovery plans. And there are ways to protect this, but I would say that's a lot of work. You have to be very successful. Michael added a nice comment here about certificates, and that is a good one because, I received my certificate as a legitimate user. It's placed, say, in my TPM on my device. That is a very good instantiation of who I really am, because my device has that certificate. So that's a very good solution right there. But things can break and people can get by. But I would say that's a lot of work someone has to do to be able to get those controls. But we can probably talk offline a little bit about that. But Michael does have a good comment about certificates. The downside with certificates, in many cases, although this is changing some, is getting those certificates to all my internal end user base. You need maybe an MDM or some other sort of tool, like group policy or something, to push those out. You have to make sure you can push those out. And then you also don't have that kind of capability if you don't control the device. But having said that, let's go ahead and move on here. Let's see. Use strong cryptography suites. At minimum, things like AES 256 for encryption, SHA-256 for hashing, but there are better ones. Let's see. Patrick had a comment here. Let's see, Patrick. Let's see what your comment is. Certificates are about to get harder to manage, dropping to 47 days by 2029. And actually, Patrick, that's news to me. Basically, you're saying that certificates are going to be required to expire in 47 days. That's that's going to make it tough. Good comment. Thanks. Now, for remote sites, as opposed to remote users for branches, I would consider using an SD-WAN solution. These are really great solutions for branches. They give you a lot of scalability, flexibility, load balancing, security. There's a lot of orchestration, automation. They're very good, particularly for lean staffs. I really like them very much. Meraki's a great solution for that. Cisco SD-WAN is also a good solution, Aruba Edge Connect, but there are many others. But when you're building WANs out, connect those remote sites, look at an SD-WAN solution. In fact, they tend to play very well with allowing you to use DIA, direct internet access, from a branch. In other words, you tunnel everything that needs to go to the data center, but stuff that you want to go out to the direct to the internet, you can do that. And they couple well with SASE solutions to make sure that DIA traffic is well protected. And here's my slide on Secure Access Services Edge, SASE. So the idea that we've got remote users that, yes, they may need to come back in securely through some sort of VPN tunnel into the data center for our private apps, but in many cases, they need to go to the internet directly, or they need to go to some of our apps or SaaS apps that are in the cloud. And we want to make sure that we can give the best user experience. We want to make sure that we can scale our internet bandwidth. So solutions like SASE solutions are great for this. Okay, not just for remote branches, but also for individual users. Some good solutions out there for SASE are Cisco's Secure Access. Zscaler has a very good solution. Palo Alto, their Prisma Access is another one. And again, there are many, many more that can do this. Historically, most folks have not wanted to do this. They've always built their remote access VPNs and their site-to-site VPNs to say, hey, all that traffic is coming back into my data center come hell or high water. And in the past, it made perfect sense because your apps were in your data center. But now more and more of the apps are not in the data center. They're in AWS or Azure, or they're a SaaS app. It makes better sense in many cases. Just let them go out to the internet straight to those applications, but let's make sure we protect that access. And that's where SASE comes in. And lastly, some extras in your spare time. DNS security. At a minimum, use a DNS solution. Some good examples are Cloudflare, Umbrella, DNS Filter, Quad9. And again, block access to all external DNS servers. And I've got this bolded in red. I reference this twice because I cannot stress enough how important this is. It's simple to implement and it's highly effective. Think about interactions between two devices on the internet, client and a server, for example. That interaction, and probably 95+% of the time, starts with the client making a DNS request, not going straight out with an IP address. They go to a DNS server because most of the places they want to go to, or almost all of them, they go to them and all they know is the name or the domain of the site they want to go to. And this is true for malware and command and control. When you get infected and there's a malware on your device that's wanting to go back to the command and control server, it's going to first do a DNS query to get the IP address of that command and control server. Well, if you use a DNS security solution, a good one will say, hey, wait a minute. From all the intelligence that we have, we think this is a bad site. This is a malware site, and it won't let you go there. So you stop that interaction in its embryonic stage, the best place to stop it. So again, implement DNS security. Some other ones, maintain DHCP event logs. I would consider moving to cloud-based networking security solutions. There are lots of benefits to that. Scalability, flexibility, simplicity. It's an OpEx model. You don't have to have hardware on-prem. You don't have to constantly scale up your hardware. So those are some things to think about as cloud-based network security solutions. Don't use self-signed certificates, even for internal IT administration purposes. Put a real certificate on there. For virtualized servers, and we all have them, don't forget that inside of a physical server that's virtualized, there are real networks in there. Make sure you secure them too, and there are lots of tools to do that. Don't forget about that part of your network. Remember, NAT is not security, and I'll say that again. NAT is not security. NAT is required simply because we insist on running IPv4, and a lot of you know my thoughts on that, but I won't go there. But anyway, NAT's not security. Just remember that. Work hand in hand with your InfoSec and SecOps teams. The more you integrate those two teams with your networking team, I think the more robust your security posture will be. And then lastly, for those who know me, you know I can't do a slide deck without saying the word IPv6, right? So it's on your network. If it's not desired, then you need to block it, okay? And there are ways to block it. If you are using it, one of the things you'd want to use are what are called IPv6 first hop security tools. And you can Google that and you'll see that the various networking vendors have ways to deploy those first hop security tools. And that's all I'll say about that. If for some reason you feel that your team, you just don't have the bandwidth to implement some of these security capabilities, but want to get there, then Lockstep can offer a whole variety of services. We can do assessments. We have professional service engineers that can do great implementations for you. We can offer managed services, and we also sell a variety of network and security products. So please, if you need help, give us a call. We'll be glad to help. And stay tuned for our next Tech Talk, Thursday, June 12th at 9 a.m., where my old friend Laddie Kelly will come on to give a tips and best practices for optimizing your Meraki network part 2. So, are there any questions? I hope this was helpful. If you would like a copy of the slide deck, send me an email and I will send you one. If you have any thoughts about future tech talks, please let me know. And if you would like to be on my email list, so you'll get word of my tech talks, you'll get word about things like the crawfish balls or other things I shoot out there. And also you'll get word about my networking classes. And as I said, I've got one seat remaining for my two-day networking basics class here in Baton Rouge. First come, first serve. If you're interested, let me know ASAP. Let me make sure, are there any questions out there? Okay, Patrick McCoy. Yeah, Patrick, I'll get you the slides. Let me take a note to do that. And very good. And I really appreciate all the feedback you folks have been providing on this call. Very helpful. And let's see. Tryon, you would like slides too. Okay, very good. I'll take that note. And folks, we will put a wrap to this. You have a great remainder of your day and take it easy.